So, same principle. A sampler, we choose one of those, I don't know, this one maybe. So first thing first, let's create an envelope and let's turn down the sustain to make it an 80 envelope. Open up the attack decay, it's that kind of shape, and then we have the basis of a whoosh, but it's not very interesting, it lacks a bit of punch. That's because we need some pitch movement. Usually for a whoosh or a pass-by or that kind of swell, I use a downward kind of pitch curve to kind of emulate a Doppler effect. So I'm gonna use an LFO, I'm gonna set it to one shot and that kind of curve maybe. And then we can assign this to the pitch of the sample. You can set it to unipolar and have it only shift the pitch upwards, or you can set it to bipolar and have it land below the root pitch. It kinda doesn't matter, just play with both. And what I like to do is, instead of using an envelope, I use another LFO and same principle. One-shot mode, and then I edit it to look kind of like this for the volume. And what's really cool about that is that I can use the grid to have kind of the sweep land on the peak of the volume envelope. And then what I can do is I can slow down both of these to, I don't know, 0.4 hertz, and then use this macro and rename it LFO rate and modulate both of these rates so that to, I don't know, 30% usually. So that now I can change the length of the whoosh and both LFOs stay sync. That kind of stuff. And then okay, it's a bit too much. And then maybe okay, maybe faster. And maybe okay, maybe some distortion. Okay, I kind of like that one. Cool. So I'm actually gonna set up a reverb, but I'm not gonna send it to the same bus so that it doesn't get printed. Kind of just a reverb to get in context and have, I don't know, have a nicer experience of doing this, because dry, it can be a bit boring. So I'm gonna send it to, yeah, group A, doesn't matter. I'm gonna call it reverb. And maybe have a bit of filtering and maybe a smudge of delay. Okay, so first of all, way less send, and then a lot less feedback, a shorter delay. Yeah, it's kind of fine like this. Print, bplant, push, tack, tack. Maybe I can make this bigger. Cool, all right, let's try with another sample. So what I like about this one is that it has those kind of swells, and maybe if we can like match that with the shape of the whoosh, we can have a more interesting sound. yeah, kind of like that, you know? So cool. Maybe I can save that one. I kind of like it a bit offset, but the start is a bit too weak. So maybe I can try something a bit crazy. I don't know. Oh yeah, I kind of like it actually. Cool. So it has some kind of articulation, which I think is cool. I think it's the kind of thing that makes it sound a bit more interesting. Maybe the start? Okay, maybe let's try a different pitch curve. Maybe like this. I think this one is nice. Maybe we can add some filter movement to add some character to it. No, not very interesting. I like it. It adds some kind of knock to it. Cool. Oof, this one is nice. Okay, I need to save that one. Okay, this is cool, but a bit chaotic up top, so maybe we can filter it somehow. Yeah, I guess it kind of works.
A few moments later.
Maybe we can try Bipolar. But then it gets way too low, so we can maybe delete that point and... I kind of like that it goes down then up. There's more interesting movements. Alright, so let's talk about FM. Let's start from an empty patch. Alright, so we need 2 oscillators set to sine waves. I'm gonna disable this one for now, and I'm gonna show you the spectrum. So, this is a sine wave, right? So I'm gonna actually play it lower, because I think it's nicer. So, this is a pure sine wave. What happens if we enable that one, if we don't send it to the master, but then take its output to modulate the phase? This is phase modulation or frequency modulation, same thing. The modulation is adding harmonics to our sound. And currently, our 2 sine waves are tuned to the same notes. And you'll get a very different sound if you pitch shift the modulator. And you'll get even weirder sound if the modulator is completely harmonically unrelated to the carrier. So I'm gonna disable the key tracking by setting the harmonic to 0 and then just input random frequencies. So you get weird metallic tones. And you can see that if the frequency of the modulator is below 20 Hertz, this is basically a vibrato. And then the closer we get to 20 Hertz, and then above 20 Hertz, you're adding partials, you're adding what's called sidebands to the spectrum. In the case of our samples, because I've made them, I know that a few of them, like most of them, but not all of them, are tuned to 50 Hertz, because I was kind of trying to emulate real-world electricity. So, and 50 Hertz is the frequency value of the AC current in Europe. So let's assume that... Okay, just for the sake of the demonstration, I made a sample of a 50 Hertz sine wave. So if I'm playing a middle C, this is a 50 Hertz sine wave. How could we tune that modulator to the sample? So the easy answer would be to disable the key tracking and then input 50 Hertz. That's the easy way. But the issue with that is that since you're disabling the key tracking, this oscillator doesn't have a root pitch, so you can't use the pitch shifting and the harmonic value. Like, this does nothing. So actually what you could do is re-enable key tracking, and what I'm gonna do is I'm gonna drop the root note of this sampler to a lower octave so I don't have to shift the modulator as much. And then what we can do is just look at the tuner and manually find the right value to aim for 50 Hertz. Minus 4.66 seems to be the right value. And the reasoning behind doing it that way is that then, let's say we make a whoosh out of this sine wave, just for the sake of the example. Right, and then an LFO, one-shot mode. All right, doesn't have to be a cool one, it just needs to kind of make sense. Now, instead of modulating the sampler that way, what we can do is modulate the master pitch of the patch. And okay, we were at like 17. And now whatever we do, since we are modulating the pitch of the whole patch, that modulator is gonna follow. So it's always gonna stay tuned with the sample. So and then of course you can detune it or you can do whatever you want with it, but it's an easy way to make sure that your modulator is following kind of the same pitch curve as the sample. So if we come back to our patch, okay. So yeah, again, I'm gonna drop this one 2 octaves so I can play it lower. Okay, this one sounds okay, I guess. And then we can create an oscillator and same, so minus 4.66. And so we're modulating how much? All right. All right, and then we can disable that one. And then we can maybe like play it higher. This one is cool. With FM, it's easy to really quickly get into kind of messy, noisy territory. So usually you'll have to use like lower values. And then we can modulate the FM amount and not have like the same sound throughout. Like maybe I can like duplicate that LFO and use it to control the volume of the oscillator. And then maybe I can have a different curve here. Or something like this. Etc, etc. I think this one is cool, so I'm gonna print it to audio. And then what you can do is completely disregard the sample's pitch and just enter random values. And you can also modulate the frequency to get kind of a sweep in the FM. Like this. Maybe we can do something that goes the other way. Okay. I don't know. It's something. Okay, but what I like even more than FM for that kind of patch is to use ring modulation. So again, let's create a new patch and then an oscillator, another oscillator. So let's disable that one and take that one and modulate the level of that one. So same as with FM, if you start very low, even like this is basically a tremolo, but with higher frequency values on the modulator, like right before 20 Hertz. As you can see in here, when we go past 20 Hertz, we add sidebands to the spectrum, which can be considered as a form of distortion. So this one is FM, let's duplicate that one, rename that one RM, and actually more than modulating the level directly here, what I like to do with RM is to add a ring mod effect here. It comes with an internal generator. But what you can do is you can disable it and use the sideband and then enable this output, set that one to 0 dB, and then send this to the sideband. In phase plant, the sideband, not to be confused with sidebands from modulation, is kind of an invisible bus that exists in parallel to the 3 main lanes and that you can send signals to from the generator section and then use as a sidechain input for some of the effects in phase plant. So maybe we can, I don't know, set it to 12 Hertz. And maybe add some distortion after. By the way, the reason I set this volume to 0 dB is that since it's modulating the amplitude, if you drop it, you lose some gain, so you need all the gain. You need all the gains, and maybe we can modulate that one. My favorite effect with ring modulation and amplitude modulation is when the modulator's frequency modulates from above 20 Hz to below 20 Hz, or the other way around. You get an effect that kind of morphs between the gritty texture of ring modulation and a simple tremolo. By the way, if you look at this zone in the output signal, you can guess in the waveform a low frequency tone that doesn't exist in the original carrier nor in the modulator, which is a cool way to show the effect of sidebands created by modulation. And actually, instead of doing it with ring modulation, what we can do is simply delete that, create a gain plugin, and then have an LFO and set it, I guess, to a sine wave. And then use that LFO to drive the volume. And because this way it never goes to 0, since there's no negative phase modulation, only positive, this becomes amplitude modulation instead of ring modulation, which has a different sound. But what I like about this is that you can make it so that it never goes to 0. Like right now it's just adding some volume and never subtracting it. You can maybe do this to compensate, but I actually think it's easier to have a second gain module and then make it faster. Okay, so I kind of like this one. But what you can do is you can then modulate the rate of that LFO so that maybe it starts as a fast modulation that just adds harmonics, and at the top of the whoosh it's just a tremolo, or maybe towards the end maybe we can try a bunch of those. So I kind of like that one. Okay, so actually maybe we can make it slightly longer. Or maybe it's the opposite. Maybe it's more interesting like that. And then you can just play with it, you know, like try different samples or add back the FM. And then maybe we can try other samples. By the way, if you change the sample here, you'll see that a bunch of stuff gets reset, like the offset, the root note. But you can lock those so that when you change samples, it stays in place. Like, I don't know, this one. Okay, it's a bit aggressive. I kind of like it with and without, so. And then this one, but less FM. Okay, one more thing before we move on to the next section is I was kind of just tweaking and playing around with the pitch curve, like the LFO curve that modulates the pitch. And I stumbled upon this shape. And I really, really like it. I have a few variations of this. So basically what this does is that there's the general shape of a sweep, like kind of like a Doppler, but in the middle you get that weird peak in pitch that actually brings kind of like a transient. And I think that's a very good segue into our next section, which is about hits.